break this up into bite-sized chunks so that it's not too overwhelming. And in this particular session, what I want to focus on is just a portion of the firewall, right? This is just one feature of the next generation firewall. And so it happens to be one of the three big core features that make this the next generation firewall. And we'll talk about more about what the heck a firewall is too. Um, but in this section right here, this will help you understand, what the firewall actually does and what makes this next generation firewall different from, say, the legacy firewalls. That's pretty intimidating right there. Looking at that, let me go. If I yeah, let me use this actually. So what I want to do is, if you take a look at the screen, I want you to look at this and say, okay, so initial packet. All right, so we start up here. We go to the right. We move over. We move over. Traditional firewalls made it this far, so they look at traffic that's going on the network, right? So you have traffic leaving your devices right now, your computers, whatever. Um, Once you have traffic going through a firewall, the firewall's purpose is to identify that traffic. Where is it coming from? Where is it going? What's going on? All right, that's the whole purpose of a firewall. These are hardware devices. Some of you may be familiar with them from a software perspective, because really, when you think about it, it's just some software running on hardware, and it could be considered an appliance. So that's how the industry buys or purchases or get involved with this type of technology. They buy an appliance. Us, we may just download some software from online, but that's not nearly, that has nowhere near the capabilities of, say, of an appliance. A firewall is built to be an appliance. And so traditional firewalls, they start here with initial packet processing. That's just meaning that, the packet, the data that's going into the firewall, it's going to look and see what's the source address. Okay. It's going to take a look and find out where to route this packet, where to take this traffic next based on a destination. Okay. And then, there may be some translation taking place. So it's going to evaluate whether or not some addresses need to translate, whatever. We get into that in another lesson. And then it's going to come down to the second tier, and it's going to basically evaluate a policy, and a policy that's going to define whether or not this particular traffic is allowed or not. Okay. And we're going to basically be looking at IP addresses and TCP UDP ports. So we're looking at ports and we're looking at addresses. So think of the ports as like windows or doors we coming through. Think of the IP addresses as the actual address on that home or that building or that residence. Okay, that's what we've been able to look at traditionally. Which block you on, which particular house you're at, and a few things about the ports that are open, how many windows you got, what kind of windows and doors you have, right? That's ports and addresses. Just an example, right? A metaphor. So that's what the firewall is really taking a look at. Any traffic that's leaving your device, leaving your phone, your computers, it has to have an IP address on your computer in order to talk to the network, and it's going to be some ports opened up in order to communicate. Now, one way that you can actually see this, you don't have to have a firewall to see this. I would encourage you at some stages here to kind of work along with me. I designed this in a way where, like, it to be hands on and engaging. So, I mean, you can, if you really want to get more out of it, you can actually kind of work along. So if you go to your Windows desktop, or I don't know if you have Mac or whatever, you can just open up a terminal window. I'm going to just go to a command prompt on Windows. And so what I'm going to do right now is I'm going to type a command called, you know what, I'm going to see if I can make this bigger. Let me pause for a second. Is everybody can hear me okay? Is everything all right? We good? Still there? Okay. All right, cool. Um, and I would say it's probably be a good idea to have some notes if you want to take some notes, get more out of this. Um, kind of like flow with it. I don't mind if you ask questions. I encourage that as well. But if it's something you don't quite get, don't hesitate to ask. I just want to make this real geekish. Let's make this green. So hopefully you can see this. Actually, I can make this a little bigger so that everybody can see this stuff. Let's go to 36. Boom. So I'm gonna type out this command. See, I feel like if everybody don't really know what their systems are connecting to right now. I mean, you it may be happening in the background. You have no clue. But one way for you to determine what you're actually connected to, there could be somebody remotely connected into your workstation right now with a remote access tool, which is called a rat, and you have no clue that it's actually happening. Your information can be leaving your system, going siphoned off to somewhere, your keystrokes, and you would never have any clue of it because you don't know how to determine what traffic is you're actually connected, what servers and what connections are made on established to your system. So one way for you to check that would be to do a netstat. It's a command. Like I said, I typed in CMD to get to the command prompt. And netstat has a couple different options, as you can see. But if you do netstat question mark, because probably a lot of y'all have a question mark about what this actually is and what it does, well, this displays the information to help you understand what this command is and how to actually use this command. So I just typed out netstat, and if I typed out netstat space dash A, this will display all the connections and listening ports. Remember we said ports, IP addresses. This will tell me all the ports connections that are currently established to my system. So, I mean, let's see what it is. So I'm gonna do a netstat dash A. Did you know that? I mean, it could be quite surprising when you take a look and see how many ports are open, how many doors and windows are open on your system, and these are ways to get in. It may be shocking to know like that you have established connections that you probably didn't even know about. Think about it. If you closed out all your browser windows and you see a bunch of connections, where is those connections coming from? Who established those connections? Where do they come from? So a firewall is in place to be able to filter, deny some of this traffic that don't need to be there. Some may be malicious, and the firewall is designed to block that, to make sure that you don't have malicious software connecting out to botnets and all sorts of other crazy things that we'll talk about in other sessions. So is everybody following us right now? Rashonda, can you see what I'm looking at? Okay, cool. All right, so that's just kind of showing you what connections are established to my system and which ports are actually open. Anything that you see that says listening, that's telling you that your system is actually listening. That means it has its ear open for that particular communication over that particular port. That's something that, again, a firewall in place will be able to mitigate any risk that you would have for having ports open on your systems. So let's get into the firewall. So again, I want to make sure that you take a look at this. We're not going to go any further than what we went in here. We started out initial packet processing. We're looking for source IP address. We're looking for the routing, where to send the traffic out, which interface it needs to go out. Because it may come in on one interface, and then based on where it's going, it may go out another interface. And then we're going to take a look and see if there's any translations that need to take place so far as IP addresses and ports are concerned. And then we're going to look at the policy and see, hey, are these ports allowed? Because I just saw a bunch of ports my system is connected to or listening on, and that may not necessarily be cool. But if I have a firewall in place, I can actually decide that, hey, this list of ports are not allowed. Okay. And therefore, there would be no sessions that are created as a result of that. Okay. Any questions about that evaluation stage of a firewall? Any questions about that? What questions do you have? What's that? Oh, really? Oh, okay. Yeah, you might have dropped off. All right, that's cool. So Rashawn, any questions about that? You good? Okay. All right. So, as a firewall engineer, of course, it's my responsibility to actually decide where the firewall goes. My particular role is, normally customers already have a firewall in place, and normally they have a legacy firewall, right? Their firewall only goes up to the point where we just discussed. All right, that's as far as their firewall goes. With the ability to check allowed ports and IP addresses, that's as far as it goes for legacy firewalls. That's why you see so many of the breaches that take place in the real world, in the wild, is because people are using legacy technology, and that doesn't work. And so the next few slides that I want to kind of get into, what the last few slides in this deck I want to cover, and it'll be about six that I'll cover. I want to really get into showing you how these firewalls, the legacy firewalls, are being just run over and bypassed really simply, very easily. And we'll kind of get into that. But I wanted to make sure that there was a good understanding about this piece right here first. So if we're good, I'll go forward. We good? All right, cool. So ports. One way I guess how you dealt with TCP ports and UDP ports. You read some of that stuff before, right, Rashonda? Okay, good, good. So like, you probably remember the port for like HTTP, right? Yep, 443. What about wait, you said no, I said HTTP. No, so no, you on the right track. So you got HTTP and you got HTTPS. So you gave me the port for HTTPS, the secure HTTP. What about just regular HTTP without the S? Remember? Nah, it's 80. Yeah. So yeah. You just gotta brush up on that stuff. You know, there's a I don't know any one way to best way to study for it other than just practice taking those tests that ask you about them. You know what I mean? You can actually remember them. There's no real rhyme or reason to why they chose port 23 for telnet or SSH for 22. You know what I mean? It's just something you just have to remember. Yeah, so it'll come with time. Yeah, it just comes with time and repetition, like you said. Yeah. So now here's the thing: when you ask people, when I've asked people, I've taught this class, like I've been all over the country, even overseas in Europe as well, teaching these courses, right? And so I'll ask people, you know, hey, what? How do you define an application? Like, what is it? Like, what would the definition of an application be? So I'm gonna ask you, what would the how would you define an application? But yeah, but what is no? I'm saying application because app is short for application. But what is an application? How would you define application? Yeah, right. It's like that. So and that's kind of tough because like from a technical perspective, tech people we're supposed to be able to clearly define these type of things, right? I mean, uh, yeah, I know, right? I mean, everybody's stuck. It's just like we use them all the time, but it's hard to really put your finger on what it is. So, the firewall has to answer this question. The firewall. I told you the primary role for a firewall. I don't care what kind of firewall it is its job is to identify the traffic and make a decision whether to allow or deny that traffic based on what it is. So from a firewall perspective, the way that applications are identified for a next generation firewall is they basically define it as anything that can be uniquely identifiable in the traffic that's going through the firewall. Okay, so I'm gonna try to explain that for you because the thing is you're learning about ports right now, and I just asked you about HTTP. Okay, which you remember which port that was? 80, right? Okay, cool. So now you can see here these are multiple different applications, but what port do you think that these applications use? Think about it. If you go from your computer to Facebook, right, or you go to YouTube, what port is being used there? What, exactly, HTTP or HTTPS, right? So we're talking about from a port perspective, all these different so-called applications are going to look alike, right? Right. So if you're just looking at just the port, that's not enough to really distinguish what type of traffic or identify what type of traffic is actually going across the wire. And so you can see that, you understand that, right? And you know, this has been this has been what it is for this long. I mean, this is where firewalls only stop at the port level traditionally. That's it. That's as far as they went. So we'll see like some vulnerabilities that can be exploited when having that type of situation. But see, the firewall's role, the next generation firewall, has the same role of identifying the application, but they use different information other than just the IP and the port number. You feel me? There's some different technology that's taking place here. There's technology that's actually, as the traffic is actually going through the wire past the firewall. The firewall is powerful enough to actually look at the traffic into the data and then identify that, hey, that matches up with a signature or fingerprint that I have for Facebook. Oh, that traffic right there, that traffic matches up with the fingerprint that I have for YouTube. And now it's able to distinguish what type of traffic is actually going across the wire, even though it's using the same port. You understand? Yeah, that's dope. This is now with that type of technology to be able to identify the applications. You can get very granular in your policies, right? You can really, decide, make some decisions here on what you allow and what you don't allow, and how much of it you want to allow and how much you don't. We didn't have that capability before, but again, that's why they call it the next generation firewall, because not only can you inspect to identify applications, but the same technology that you use to identify applications is the same technology that you use to identify threats and to identify viruses. So now we bring in antivirus, we bring in this type of layer of protection up to the edge, to the firewall, where it doesn't make it into the network now. Do you get it? Yeah. So that's pretty dope. That's pretty powerful technology to have a grasp on these because you can instantly see the demand for something like that, right? You can see, that an application is complex. There's really no clear definition of what an application is. It's just a matter of you know being from a firewall perspective, being able to have the intelligence to actually dig into what is passing through the firewall at a higher level. You should be learning about OSI reference model, right? Okay. So again, you studied it, but how much you remember? what's layer one? What's, la- what's layer one? All people say they need data processing or something like that. Yeah, I mean, it depends on which way you do it. I mean, that's starting from seven going down to one. Mm-mm. Nope. So here's how I'm gonna help you out with a little bit of that. So the very first layer, layer one, all right, the first thing, and I want you to apply this to like you. I apply this to my troubleshooting. So if somebody comes to me and they say they have a problem, right? Oh, the internet's not working. Okay, I use the OSI reference model as my guide, and I start with layer one. Well, what's layer one? Layer one is the physical layer. It's the stuff that you can actually touch, like the cables, the wires, the NIC card, the physical stuff. So a lot of times, if somebody says something don't work, I'll come over. I'm looking for the cable because I can't tell you how many times I done went to service somebody, help somebody out, and I'm just end up plugging in the cable. Okay, that's the physical I can touch type layer, right? And then you work your way up from there. I mean, it's not as easy. I mean, but if you know that much physical, that's your P. You can kind of work up from there, right? So, data link layer is your layer up, going up. So that's layer two. Okay. Now, now data link layer, that's more where you have your MAC address. So you'll see MAC addresses is that's the address that's burnt into your NIC card. Your NIC card is your network interface card. So that card that interface with the network that you plug into, or maybe it's wirelessly connected to, that really operates. It's physical, but it has a layer two address on it. It's called a MAC address. So every link that you connect to, whether you connect it to your router, it has a MAC address on it. So they call that the data link layer. That's the data link layer. That's layer two, and then up from there you get to your your network layer. That's where you see IP addresses. You hear me talking about IP addresses. So the next layer up from that, and we'll stop there, is layer four. That's where your ports are. TCP, UDP, those protocols operate at layer four. All right. So now when I say layer four firewall, you know what I'm talking about. You know I'm talking about IP addresses, which are layer three, and I'm talking about ports that are at layer four. Now, if you can conceptualize that layer four up going up only layer four, that's as far as firewalls go, then now you can conceptualize a next generation firewall actually going up to layer seven. So what's that layer seven? Exactly, application layer. All right. So now that's where we get deeper inspection, and we're able to make better, more informed decisions at layer seven. So I'm gonna go through this real quick. Let me see what we're doing on time. And I think you the only one. Okay, cool. All right. So let's take a look at this example right here. Now there's a particular type of application that is referred to as evasive. Okay. And I just wanted to show you an example of this. And this kind of drives through the point of why the old legacy firewalls are so outdated, and they don't work for what they're supposed to do. Now, when I go talk to firewall engineers, because again, I'm training firewall engineers, um, and I ask them, okay, you get a request from your boss to make sure that no one is able to use Yahoo Messenger. I know Yahoo Messenger is so old and it's probably like really like dated, but we can think of it as anything, whatever. It could be some other messenger. But anyway, Yahoo Messenger. I asked them because these are usually older guys and they can relate to Yahoo Messenger. So I say, okay, if you had to block Yahoo Messenger, how would you do it, right? And so, I mean, I know you're not a firewall engineer or nothing, but what would you? How would you answer that, Rashonda? Yeah, you set up a firewall, but on there you gotta tell it to do something. What would you tell it to do? You gotta configure it. Yeah. So how do you stop it from communicating? I don't know. You tell me. I'm asking you. How would you stop? So you say your main point is you said you want to end the connection. You want to block it from connecting, right? All right. So how does it connect? I mean, what port does it use? That's the question that you will want to ask. Is like, okay, well, you got Yahoo Messenger. Let me see if I can get you something. Let me show you something real quick. Because traditionally, let me see, what is the TCP UDP port list numbers? Let's see what that do. If it's the IANA one, then that's good. Let me see if I can get to that real quick. IANA.org. So that's where the list of ports are located. So here you'll see there's 65,535 ports. So the list of well-known ports that you're studying right now are under 1043. Is that right, Rashonda? The list of well-known ports, are they you remember what is it? 1040 something, right? You don't remember? All right. All right, so yeah, so under 1020 under 1043 is where you'll find all the well-known ports. And then once you get over 1040 or something like that, or 1023, once you get over 1023, then it's kind of fair game from that point on. But if you ever need a resource to come to find out what port a port number is, you could come over to this iana.org site to get that list. All right, this will tell you a list of the port numbers for each different application. Yeah, iana.org. All right. So traditionally, what you would do is you'll find out, what port, and I would say TCP port. What TCP port does Yahoo Yahoo Messenger use? This is normally along the lines of the answer that I would get from somebody. They will go research and find out what TCP port the um the Yahoo Messenger uses, and then what they would do on the firewall is they would actually block that port. Yeah, so that's what firewall engineers have been doing. With Yeah, yep, that's the fourth layer of the OSI. Yep, that's right. Yep, yep. So that's cool. So that's good that you got that, because again, you know, at layer four, you have some issues because say, as an engineer, you say, okay, well, Yahoo has documented that it uses 50/50. All right. Well, what I'm gonna do is, as a firewall engineer, I'm gonna put in a rule to block port 50/50, right? And then so that's normally what happens. We'll get into that, writing of the rules and stuff later. But basically, you block, whatever port, and then that's how port-based firewalls work. Okay. Now, the thing is, applications start getting smarter. All right, and some applications, they make it available to smart users to actually change the port to something different. So now, if a firewall engineer actually blocks a particular port and the application decides to go in on a different port, and what's significant about that port 80? What's that port 80 again? Yeah, but what is it used for? Exactly. So that's one of the ports that you really can't close, right? Exactly. And so these applications and attack and hackers, of course, too, right? They know how to channel their traffic over ports that are likely open, and then that's a way for them to get inside. Do you understand that? Okay, cool. So let's take a look at a traditional firewall versus a next generation firewall and see how it behaves differently. I think this is the best way to get a good understanding of what the difference is and why it works the way it works. Okay, because the full focus of this particular module, I think I probably this is probably the last couple slides right here too, and then we'll get right into some some actual hands-on stuff. But the main point here, what I want you to understand is why it works the way it works, and the fact that we're talking about application ID or app ID. That is a feature that allows the firewall to inspect the traffic at layer 7 instead of layer 4. We already defined the fact that layer 7 is our application layer, and layer 4 is our, what is the layer 4 called? There you go, because you're looking at the book. That's what I'm talking about. So yes, you got transport, and then you got application. I was joking, but you did. I mean, I hope you got some notes there, though, right? Something to look at. All right, cool. That's good. So so transport layer, yeah, you said layer 4, the application. There's a lot more that you can learn from looking at the application layer. So let's say here's a DNS packet coming through, right? So if you don't know it already, every time you go to a website and you type in the name of that website, you type in a name. Well, computers don't work like that. Computers communicate and connect to one another over IP addresses and ports. Okay. Well, not everybody knows as much as you know, Rashana, so they don't know that DNS goes over port 53 and that HTTP goes over 80 and all that stuff, right? They don't know that stuff. But for a firewall, when it sees traffic, a traditional port-based firewall sees any traffic going over 53, it automatically assumes that that's DNS. So it's going to give it the green light and allow that to come on through. Okay. Now, when the next generation firewall, Palo Alto CDNS, you're going to do the same thing, right? You see DNS, it actually, we know that it's DNS, not just because of the port that's being used, but we actually take look at the port and we actually look at the actual data to make sure that it matches to what DNS really is. Okay, because we don't want to be in a situation where somebody's sending some traffic over that port 53 that ain't really DNS traffic. So that's the difference with layer 7 inspection versus layer 4. So now you got BitTorrent coming in here on a port-based firewall. Are you familiar with BitTorrent, Rashonda? Okay, so what about like I mean, you've seen like, I don't know, what are the BitTorrents? Give me some other BitTorrents. But some BitTorrents, like different ones. uTorrent, other stuff. Torrents. Yeah. Pirate Bay. Pirate Bay. Yeah. Okay. So anyway, these is just like sites where it's peer to peer sharing. Okay. So if you had a movie and you wanted to get it illegally, then you can go to these peer to peer network environments. Yeah, right, and watch movies and all that stuff, whatever. But anyway, it's something that's banned on real networks, right? They don't want that stuff up. So, all right, so the BitTorrent traffic comes through on port 53. It's allowed on a port-based firewall just based off the strength that is going over 53. Now, what's going to happen here? What do you think is going to happen here when it comes? That's right. Why? Not because of the port. Yeah, the port looks fine, but it's going to take a look and see that that traffic does not match up with what DNS is supposed to be, and so it's going to be denied. So what happens in a traditional environment is they have to actually purchase an additional device that's called a IPS. So IPS is an intrusion prevention system. Okay. Now, an intrusion prevention. Have you heard of an intrusion prevention system before? Okay. So that's just another layer of security that exist in traditional environments because again the firewall is just getting run over. So they had to add some other layer in there to try to, you know, handle the situation that they're facing, which is they can't identify traffic based on layer four. So with the IPS has a database of signatures, and then so therefore the firewall has to send the traffic over to the IPS, so the IPS can take a look at it, and then the IPS send the packet back to wherever it need to go. Okay, so that's the old school way of doing it, and then of course you have the same situation where you have DNS come in. It's gonna go through the firewall, get inspected by the IPS. Now, when BitTorrent comes through the firewall, we know that that's going to get right through. Now, when it comes to the IPS, because it uses signature based technology, it's actually going to stop it. So that's cool. And that's really all that they had before. But now, when we take a look at a 0 day, and 0 day, I would say will probably be some of the worst. I mean, in my opinion, these are the worst threats in the internet right now. A 0 day. Have you heard of a 0 day before, Rashonda? Okay. So here's what a 0 day is. If you have if there's a vulnerability that exists, and the vendor, say Microsoft, they know about it. What do they normally do? How do what do they do? Okay, so say Microsoft finds some type of flaw, right? And they find some type of vulnerability in Windows, whatever software. What do they? How do they normally remedy that issue? Yeah, they issue some patches out, right? And so that's that's how everything. So that's why everybody say, hey, make sure you have your updates and your patches, right? Because that's going to protect you from all the security vulnerabilities that they found and that other researchers have found. That's the only way to patch it up. Now, if you don't do that, then guess what? As an attacker, I kind of know, what you're vulnerable to. I mean, I kind of know how to get into your system if you didn't install the latest patches because it becomes public information. What that patch fixes, and that's just it's out there. So again, when it comes to that information, those signatures, and I kind of lost track based off of the question that you asked, but I started talking about the signatures. Um, Let me make sure I'm answering your question correctly, Rashana. Okay, I just want to make sure I was answering your question because we started to talk about the signatures that's used on the IPS, and then I started explaining something else to you. But I'm gonna just kind of stay on this BitTorrent thing. So now you see the BitTorrent coming through. You know, the 0 day is really kind of like what happens if you don't have a patch. What happens if you don't really know that there's a vulnerability there? That means that you can't create a patch for it. That's what's referred to as a 0 day. This means that nobody but a select few people know that there's an actual threat, a vulnerability, and there is no patch for it. So if there's no patch, there is no signature, nobody knows how to identify it, then you can't possibly how do you fix that? Can you fix that? Yeah, it's kind of tough. It's tough. It's tough because, like I said, the IPS, right? This has a database of different signatures, just like fingerprints, right, for bad guys. So when it comes here, it's gonna check to see what it is and match it up against this database of fingerprints. But what I'm saying is, the 0 day malware, it doesn't even have a fingerprint set. So of course, if it comes to the firewall over 53, it's gonna go right through. If it gets to the IPS, it's gonna get right through. Now, I told you about the 0 day. What's gonna happen here on the next generation firewall? Explain to me what you think is gonna happen here. But but why though? Port. Remember layer 7. What's that layer 7? Exactly. So when you look at the application, the DNS application, that's not gonna match up with this malware, this 0-day malware. So for that fact, even though we don't know what it is, the firewall never seen it before. Just for the fact that it doesn't look like DNS, it won't get through. That's how it protects you from 0-day, from unknown threats, is because if it comes over port 53, it has to be DNS by an application layer, right? And this has like rules, strict rules that looks for specific code or specific information that is only in a DNS packet. And so that's how it protects against unknown threats. So yeah, that's it there. What any questions you have about that? All right, cool, cool, cool. All right, so that would be about an hour. Um, so what I'll do here is I'll pause, and I'll just kind of any questions that you have about what we talked about, um, anything, any feedback. Mm-hmm. Cool, cool. Yeah, you know what? I just realized. Oh well, I am recording actually. I am. Yep. I do. Yep. So I do have a recording um of this, and I should be able to make that available. I thought for a second that I wasn't recording because I didn't see the light on. But yeah, yeah. So that'll be something I could possibly make available. Yeah, I have to. I'm probably gonna host it on the website some kind of way that I haven't figured out yet. I'll probably create a separate page for it, and then you'll be able to access it that way. If that becomes, you know, a time thing where I can't get to it right away, I'll probably find another way to share it. Maybe through like I could throw it onto Canvas. That's one way I can do it, and then have you download the Canvas app and you can do it that way. The last thing I could probably do is put it on Google Drive or something like that. But yeah, give me a couple of days to kind of edit some stuff up, and then I'll have it available. And actually, I'll probably use that for everybody else that couldn't make it this time around, and we'll probably do it like that. But okay, that's good. Good feedback. Good feedback from you, Shonda. My battery's dying. Um, so yeah. So what I would do, like I said, the next stage here would be to actually, go into the project work, right? So I have a project right now to actually, because when you're going from say legacy firewall over to the next generation firewall, you're gonna have port-based rules that now need to get converted over to app ID rules. And so I gotta pretty much go to work right now to actually do that for a customer, where I'm gonna assess their layer 4 rules and then kind of give them a quote for what time I would need to kind of convert them over to app ID rules. And so we will work together on that. I will have you download the migration tool, and then we can kind of work with the config, and just kind of work on it. Just do the same thing. Just work on it together. You feel me? Yeah, yeah. So that's what it is. I think my computer is about to die, but yeah, that's pretty much what I had. I'm glad you could make it, Rashonda, and especially I'm gonna keep saying it. You made it on time, so that's freaking awesome. I appreciate it, and you got some good training out of it too. So um, yeah, I appreciate it. So anything else you have? Okay. Yep. I'll let you remind me by if you don't hear from me by the end of the week. Remind me about that video making that available to you. I'm gonna try to work on it after I get finished with the assignment that I have. But yeah, if you don't get back from if I don't get back to you before the end of the week, make sure you remind me about that. All right. Okay. All right. Okay. Take care. Have a good night.